The mean corpuscular hemoglobin concentration, a measure of the concentration of hemoglobin in a given volume of packed red blood cells. It is reported as part of a standard complete blood count. It is calculated by dividing the hemoglobin by the hematocrit. Reference ranges for blood tests are 32 to 36 grams (dl), or between 19.9 and 22.3 mmol (L). It is thus a molar concentration. Still, many instances measure MCHC in percentage, as if it were a mass fraction. Numerically, however, the MCHC in g/dl and the mass fraction of hemoglobin in red blood cells in percent are identical. Assuming a RBC density of 1 gram ml and negligible hemoglobin in plasma. Interpretation: MCHC is diminished in microcytic anemias and normal in macrocytic anemias. MCHC is elevated in hereditary spherocytosis, sickle cell disease and homozygous hemoglobin C disease. This count is used to give a rough guide to what shade of red erythrocytes will be. Complications with cold agglutinin. Because of the way automated analyzers count blood cells, a very high MCHC may indicate the blood is from someone with a cold agglutinin. This means that when the blood gets colder than 37 degrees Celsius, it starts to clump together. As a result, the analyzer may incorrectly report a low number of very dense red blood cells for blood samples in which agglutination has occurred. This problem is usually picked up by the laboratory before the result is reported. The blood is warmed until the cells separate from each other and quickly put through the machine while still warm. This is the most sensitive test for iron deficiency anemia. There are 4 steps to perform when an increase MCHC is received from the analyzer. Remix the EDTA tube. If the MCHC corrects, report corrected results. Incubation at 37 degrees Celsius. If the MCHC corrects, report corrected results and comment on possible cold agglutinin. Saline replacement. Replace plasma with same amount of saline to exclude interferon C, G, lipemia and autoimmune antibodies. If the MCHC corrects, report corrected results and comment on lipemia. Check the slide for spherocytosis, autoagglutination, falsely RBC and MCV, lipemia, falsely hemoglobin. Hemolysis will falsely increase the MCHC and falsely decrease the calculated hemoglobin. Other Heinz bodies may falsely increase the MCHC but not the MCH. Agglutination falsely increases the MCHC. The MCH is more accurate in this setting. Excess EDTA dehydrates RBC, falsely increasing MCHC in MCH. Worked example.